Hello students, welcome back to the next module. In the last module, we have already covered till question number 10. We will start with question number 11. See, this is a particular question which is given in the textbook. You have to find out the value of x and y. So, how do we do that? Here x acts as a scalar multiplier. We multiply x with 2 and 3. Both the elements in the matrix. So, what do we have? 2x plus 3x. Similarly, we multiply y with minus 1 and 1. So here we have minus y and y here. And this 10 and 5 will be as it is. Now, we'll be adding up corresponding elements. So what do we have? 2x minus y. And here we have 3x plus y. And this is equal to 10 and 5. So we formulate two equations. One is 2x minus y equal to 10. And the other one is 3x plus y is equal to 5. Likewise, on elimination, we calculate the value of x as 3 and on substitution, the value of y is equal to minus 4. Right? We move on to question number 12. In question number 12, this is what is given to us. We have to find out the value of these variables. So what we will do is, we will add up these corresponding elements. And this is what we get, minus 1 plus z plus w, 2w plus 3. And left hand side, we have this particular matrix. On solving, this means we have to multiply every element of this matrix with 3. So we get 3x, 3y, 3z and 3w. And this is equal to 4 plus x, minus 1 plus z plus w, 6 plus x plus y, and this is 2w plus 3. Since the order of the two matrices is the same, what do? We consider them to be equal matrix. So if we consider them to be equal matrix, we compare the corresponding elements. That is 3x is equal to 4 plus x. Likewise, 3y is equal to 6 plus x plus y. 3z is equal to minus 1 plus z plus w. And 3w is equal to 2w plus 3. So on transposing, 3x minus x will be 2x. Therefore, x will be equal to 2. Putting the value of x as 2 over here. So we have 3y is equal to 6 plus 2 plus y. Taking y over here, so we have 2y is equal to 8 or y is equal to 4. Right? In the next, we have this and we have this particular equation. Let us solve the value or find out the value of w first. So we have 3w minus 2w, that is w is equal to 3. Likewise, for this equation, 3z is equal to minus 1 plus z plus 3. So transposing, we get 2z is equal to minus 1 plus 3, which is 2. So 2z is equal to 2 or z is equal to 1. So in this way, we are able to find out the value of all the 4 variables. Right? Okay. Next, we come on to question number 13. Here, a function in x is given to us in the form of this particular matrix. We have to show that fx and fy. This means the product of fx and fy is equal to f of x plus y. Now what does fx means? Fx means a function defined, a matrix defined in terms of x. Fy will mean a matrix defined in terms of y. And f of x plus y means a matrix defined in terms of x plus y. So how do we do this? Fx we already know, given to us. Fy, this means we have to replace this variable x with y to convert this into the function y. So we have cos y minus sin y 0. This is sin y. This is cos y. This is 0 again. 0, 0 and 1. And now what we will do is we begin with the left hand side. And what is the left hand side? Left hand side means we will be finding out the product of fx and fy. So once we find out the product, this will be cos x, sin x, 0, minus sin x, cos x, 0, 0, 0, 1. And this will be cos y, sin y, 0, minus sin y, cos y, 0, and this will be 0, 0, and 1. Simply, we will be multiplying. Since these are 3 by 3 matrix, the product will also be a 3 by 3 square matrix. So cos x into cos y will give us cos x, cos y, minus sin x, sin y, and this will be plus 0. So let it be like this. Then this row and this column needs to be multiplied. So cos x into minus sin y. You have cos x minus cos x sin y. Right? And this will be minus sin x cos y. This will be 0 again. Likewise, on multiplying, we get sin x cos y plus cos x sin y and 0. Here we have sin x, sin y, cos x and cos y. And this will be 0 again. Here we will have 0, 0. This will be 0, this will be 0. Likewise, all the elements here will be 0, 0. But here, at this particular position, we have 1. On multiplication, you can easily find this out. Now, what is cos x cos y minus sin x sin y equal to? This is equal to cos of x plus y. Remember, cos x cos y minus sin x sin y is equal to cos of x plus y. Now, minus cos x sin y and minus sin x cos y. I can take minus sign common over here, and what do we have? We have sin x cos y plus cos x sin y, which can be written as sine of x plus y. 0, 0, 1, and here also we have this as 0. Again, sin x cos y plus cos x sin y can be written as sine of x plus y. And here we have forgot to mention the sign. So this one is minus sin x sin y. So we take cos x cos y minus sin x sin y. So this becomes cos of x plus y, right? So if we compare this particular function with the given function, right? So here we have cos x, here we have cos x plus y. Here we have sin x, and here we have sine of x plus y. Here we have a 0, here we have a 0. These elements are okay. And here we have minus sin x, here we have minus sine of x plus y. Here we have cos x, so here we have cos of x plus y. So the two have the same kind of functions, but one is in terms of x, y, and the third one is in terms of x plus y. So I can write this as a function of x plus y, which is our right hand side. Therefore, we can say LHS is equal to RHS. I hope it's clear to you all, right? Okay. Next, question number 14. In question number 14, first and the second part, as you can see the matrix, let me take this as matrix A, this as matrix B. Likewise, I take this as matrix B and this as matrix A. Why? Because as you see, the two matrices, right? This matrix and this matrix is the same, but their order has been reversed. And in one property of matrices, multiplication, I told you that AB is not commutative, will not be equal to BA, right? So this is what you have to prove on simple multiplication, that the two, that is AB, is not equal to BA, right? So students, you please do this question number 4, part 1 and 2 in your notebooks. Okay. Meanwhile, we move on to question number 15. We have a square minus 5a plus 6i. We have to find out its value. If a is given to you as this given, matrix. So how will we do this? See, we'll be finding out a square first. That is, this is 2, 0, 1. This is 2, 1, 3, 1, minus 1, 0. This is again 2, 0, 1, 2, 1, 3, 1, minus 1 and 0. Now on multiplication, we see 2 into 2 becomes 4. So we have to fill up these 3 positions. And how will we fill these 3 positions? Remember, corresponding multiplication. So we have 4 plus 0 plus 1. So 4 plus 1 is 5. Likewise, this will be 0 plus 0 minus 1. So this becomes minus 1. Likewise, 2 plus 0 plus 0. So this is 2 again. Likewise, 4, 2 2s are 4. This is 2. So 4 plus 2, 6. 6 plus 3, 9. Likewise, 2 into 0, 0. 1. And this is minus 3. So that's minus 2. 2 plus 3, 5. And here we have a 0. This and this. So that's 2 minus 2, 0 plus 0. So that's 0. 0 minus 1, 0. Again minus 1 over here. We have 1 minus 3. That's minus 2 plus 0. So this is a square, right? We have to find out the value of. Now let's arrange a square minus 5a plus 6i. So instead of a square, I can write 5, 9, 0, minus 1, minus 2, minus 1, 2, 5 and minus 2. Minus 5a is 2, 0, 1, 2, 1, 3, 1 minus 1 and 0 plus 6i. Identity matrix, since all the matrices are 3 by 3, so identity will also be 3 by 3. So this is 1, 0, 0, 0, 1, 0, 0, 0, 1. So how are we going to do this? Just simply write this as 5, 9, 0, minus 1, minus 2, minus 1, 2, 5, minus 2. And here 5 into 2, 10, 0, 5. And here you have 10, 5, 15. And here you have 5, minus 5 and 0. Plus this will be 6, 0, 0, 0, 6, 0, 0, 0, 6. So on adding, 5 minus 10 will give you minus 5. Minus 5 plus 6 will give you 1. Right? Minus 1, minus 0, plus 0. So this will give us minus 1 here. 2 minus 5 is minus 3 plus 0. Again 9 minus 10, minus 1 here. Minus 2 plus 5. Minus 2 minus, here we have minus 2, minus 5, minus 7, plus 6 will give us 1. Again, 5 minus 15, minus 10, right? Here we have 0 minus 5, plus 0, that's minus 5, minus 1, plus 5. Minus 1 plus 5 will give us 4. Minus 1 plus 5 will give us 4. 4 plus 0 will be 4 only. Then we have minus 2, minus 0, plus 6. So that becomes 4. So this is the matrix that we have to find out. I hope it's clear to you all, students. You have to just proceed step by step to complete the question. Next, very important question. That is, we are given matrix A and we are given identity matrix. We have to find out the value of K so that A square is equal to KA minus 2I. So we will just get started with this particular question. That is, we are given matrix A, 3, minus 2, 4 and minus 2. we have to find out the square of A. So this is 9 minus 8, which is 1. This is minus 6 plus 4 minus 2. This is 12 minus 8, 4. This is minus 8 plus 4 minus 4. So this is A square. Since we have this relation is equal to Ka minus 2i, A square is 1, 4 minus 2 and minus 4. K, A is 3 minus 2, 4 and minus 2. Minus 2i, 1, 0, 0, 1, since we are talking about a 2 by 2 matrix here. So that is 1, 4 minus 2 minus 4 is equal to 3k, 4k minus 2k minus 2k, right? And here we have 2, 0, 0 and 2. Okay. So we have 1, 4 minus 2 minus 4. And here we have 3k minus 2 minus 2k, 4k minus 2k minus 2. So if I take 3k minus 2 equal to 1, what value do I get? 3k is equal to 3 or k is equal to 1. And as you can see, if I take these corresponding elements, since I consider them to be an equal matrix, so 4 is equal to 4k, then also k is equal to 1. Likewise, if I take minus 2 is equal to minus 2k, so k is equal to 1. Therefore, my assumed value is exactly the same as the value it should be. So we have k is equal to 1. I hope it is clear to you, students. Please practice all these questions until we continue with question number 18. Thank you.